Hey, good morning, students. Here is slope-intercept form. Actually, lesson 5.3, part 2. And we're going to graph some slope-intercept form questions here. Okay, if you look in your book, and I know we're just doing this by videos, but I highly encourage students to look in the books too, not just to, listen to me and do homework. Not that there's anything wrong with listening to me and doing homework, but it's on page 334. Now, today's question is, how do you graph with slope-intercept form? So I made a nice coordinate plane here, and I have an equation. Y is equal to 2x minus 1. Okay, it's the same equation that's in the book on page 334, so you can look at it. But I actually want to put it together, so if you have graph paper, you might want to follow along with me on these steps. So how do I graph the equation y is equal to 2x minus 1? Using the fact that this is in slope-intercept form, okay? Now, slope-intercept form, as I am asking you to memorize, is y is equal to mx plus b, okay? Now, I wanted you to take just a minute to review the forms that I'm trying to make you memorize. The first one is the slope formula. y2 minus y1 is over or divided by x2 minus x1, okay? And then you have direct variation, y is equal to kx. And then you have the parent form, the linear parent form, y is equal to x. And then the function form of the linear parent form, which is f of x is equal to x. And then you have the slope-intercept form, which is y is equal to mx plus b. Now this is the most important one. Out of everything I taught you, this is the one I want you to know because you're going to be using it more than any other form. Okay, so let's go over the parts again. Y is your y coordinate, x is your x coordinate, meaning your ordered pairs. Okay, m is the nickname for slope, and b is the y-intercept. Okay, so in slope-intercept form, how do we graph this? Now I want to remind you, you can always make a table of values. Okay, but slope-intercept form can save you the time because you and I both know that making a table of values to solve like 5, 6 different equations. Well, what x values do I use? Oh, that x value doesn't graph very good. You avoid all of that. Okay. So the first thing I want to start with is the end. As they say, the last will be first. So the last part of it, b, is my y-intercept, -1. So -1, the y-intercept, is the point where it crosses the y-axis. So I start at 0, 0, and I go down to -1, and I make a point there. Now, if I had a table, then that point would be 0 for my x value because I did not go left or right for my x value, and -1 for my y value because I went down. Remember, down means negative on the coordinate plane. So the y-intercept is the point 0, -1. Now I've already got 1 point. Now, looking at the equation, I know that this is a linear equation. Now, I usually have kind of a saying, 2 points can create a line, but 3 points verify it, okay? Now, if you have any question of whether or not your equation is linear or not, then the best thing that you can do is to put at least 3 points, okay? But in this case, I know that this is a linear equation, so 2 points would be sufficient. So I've already got 1 point on there to make the line. Now I need to make another point. Well, again, I could do a table of values, but let's take a look at the slope. The slope is 2, and 2 can be defined as 2 over 1. Remember, any whole number can be written as a fraction over 1. Now, my slope is defined as rise, my upward change, over run, my horizontal change. Okay? I just want to make sure that you can see that. Rise over run. So go to the point that we already have figured out, and following the value of 2 over 1, I can go 2 up and 1 over. And there's my next point. Okay, now take a look. I went 2 up and I went 1 over. Now, like I said, 2 points make a line, but 3 verifies it. So I'm going to make another point. 1, 2 up, 1 over. 2 up, 1 over. Now, by using the slope of going 2 up and 1 over, I now have a line. Now, I'm going to use a ruler here. Any straight edge, I even use the edge of a book or a pen sometimes, but this time, since I have it available, I'm going to actually use a ruler. Okay. And that is how you graph from slope-intercept form. So let me write the steps. Step 1, use y-intercept to make the first point. Okay, since we know that b is the y-intercept, b meaning the number that is the last number in slope-intercept form, then all I have to do is go to that point on the y-intercept. If I need to know it as an ordered pair, then the x value is always going to be 0, because if it's on the y-intercept, the x value is always going to be 0. For example, if this was positive 4, then I would go 1, 2, 3, 4. Okay, if it was plus 6, I would go 1, 2, 3, 4, 5, 6. If it was minus 2, I would go 1, 2. If there's nothing there, if it's just y is equal to 2x, then I can think of it as y is equal to 2x plus 0. So then I would just leave it right here and know that my point goes right through the origin. Okay? So the first step is to use the y-intercept to make the first point. And then step 2 is to use the slope to rise and run to make more points. Use the slope to rise and run. Remember, go up however many your numerator is, go over however many your denominator is. Okay? I'm going to write a little hint here. Make sure to write your slope as a fraction. Okay, so let me review. Given that your equation is written in slope-intercept form, if it is in slope-intercept form, then the slope is obvious and the y-intercept is obvious. The y-intercept will give you your first point, and the slope can give you other points after that. Okay. Now, as you can see, my line goes down here. So if I wanted to include some negative points, then I could go 1 back, 1, 2, down. Looks like I kind of, my ruler must have been off. I think I missed the line a little bit there. It's my mistake. But the idea still works the same backwards. 1 back, 2 down. 1 back, 2 down. And you can continue making points that are actually on the line. Okay? All right, I hope that helps. There's also problem 6, which kind of goes into modeling a function. It's a little bit complicated. I kind of disagree with the book. They picked some complicated, decimals. I dislike it when it does that, because I feel like make a simple problem so you can understand how to do it, and then apply the complicated problems to it later. But anyways, modeling a function, it says physics. Water pressure can be measured in atmospheres called ATMs. Use the information in the diagram to write an equation that models the pressure Y at the depth of X meters. What graph models the pressure? Now, I I sort of like and dislike the book in this. I like that they use a real world example. I dislike that they expect you to know all of the science involved behind these numbers in order to answer this, because there's a lot of people that are not involved in, you know, atmospheric pressure questions, or if you're not like a professional diver, you probably have no idea what they're talking about. Okay? But given, we can still go ahead and make this. Given what we know is that y represents the pressure and x represents the meters. Okay? So using slope-intercept form, you can go y is equal to mx plus b. Now it says identify the slope and y-intercept. The slope is the rate of change at 0.1 atms per meter. Okay? So, like I said, I don't like that they use a decimal, but hey, we've got to work with decimals at some point in our lives. So substitute 0.1 for m, the slope. Now, one of the interesting things here is, remember in lesson, I forget which lesson number, I forget if it was 5.3 or 5.1, but it talked about slope and it compared it to rate of change. So 0.1 atms per minute is actually the rate of change. But when you put it in a graph, then it becomes the slope. So rate of change and slope are the same thing in essence, okay? So if you have a question where there's a rate of change, then you can substitute it in as the slope for graphing, okay? And then so substitute 0.1 and then 1 for b, okay? And the y-intercept has starting value is at 1. Now, if you look on the graph here, they only graphed the top right quadrant here, but it starts at 1, so your y-intercept is 1, and then it would continue on in this direction. Now, they only put 2 points on there, but it just shows that sometimes you can read a word problem, find the parts, and then stick it into the slope-intercept form. Okay? I hope that helps. Enjoy the lesson.